Alright, this is the review for the county formative that's coming up in a few days on Thursday, and this is for Unit 3, Topic 1. So I'm going to just work through the answers to all the problems, and hopefully you will find this helpful. Alright, first we have a couple of volume problems, and we know that the general formula for volume is volume equals capital B, which is the area of the base, times the height. That's what we use for volumes of prisms and cylinders like number 2. So for number 1, this is a triangular prism because it has parallel triangular bases with rectangular sides. So the triangle is the base, so we need the area of the base. Then the height is that distance between the two bases, so that's going to be 13. So let's put this together. So the area of the base is going to be 1/2 base times height, because that's the area of a triangle, then times the height of this prism, which is 13. Alright, so if we multiply these all together, and this is a calculator problem, so let me see what I get here. So I'm going to do 0.5 times 7 times 5 times 13, and I get 227.5, and this is in feet, so it's feet squared, because we're talking about, it's volume, so we're not talking about squared, we are talking about feet cubed. Alright, next one. So this is a cylinder, and what makes it a cylinder is that it has a circular base. So we just need the area of the base, and then the height of the cylinder, you can see, is 10. So the area of the base, this is the area of a circle, that's pi r squared. That's our formula for the area of a circle. And then times our height. And this will be 49 pi times 10. That's what I get when I square 7. And then 49 pi times 10 is 490 pi, and that's inches cubed. Now you can leave it in terms of pi. You could also put 3.14 in for pi, and if you do that, then your answer would be 490 times 3.14. That would also be 1538.6 inches cubed. Alright, let's see what's next. Alright, in these problems you are trying to identify the solid given this particular net that is being drawn. So you're trying to take these figures and fold them into a three-dimensional figure and name what that three-dimensional figure would be. Now, there's a couple of tricks that I can show you that will help. So whenever you have these two separate pieces like this, you are more than likely talking about a prism, and these separate pieces are going to tell you what kind of prism. So we have that here, we have that here, you see we have these two little outlying pieces, you have that here, and you even have that here with these two triangles. So these are probably going to be prisms. So on number 4, we have a pentagon as our base, and the sides here are going to be your height. So this is actually what we'd call a pentagonal prism, because our base of the prism is a pentagon. For number 5, this is a simple one. This is just a rectangular prism. We like those, nice and simple. And let's skip to number 7. When our base is a circle and we wrap this around, that's going to be the side. This is a cylinder. So we have the bottom and the top, and then the around that between the bottom and the top gives us a cylinder. We'll come back to 6. And then number 8, you can see we have these two triangle bases, and then this will wrap around and be between those two bases, so this is a triangular prism. Alright, so that takes us back to number 6. And we don't have, an outstanding 2 pieces, we actually have 4 pieces outstanding. So if you can visualize folding each of these pieces up, they all come to a central point. And a figure that has a central point like that is a pyramid. And we name the pyramid by the base. So this looks like it's at least a rectangular base, but I think it's probably a square base. Generally, you won't have to assume that, but I am gonna assume in this case. And when I fold this up, that it's the base and folds up to the top. So this is a square pyramid. All right, moving on. So in these problems, these are about what we talked about when you slice a three-dimensional figure, and you talk about the shape of the cross-section that's created when you slice these figures. And you can slice them in different ways, right? You can slice them parallel to a base, you can slice them parallel to the base, you can slice them, I think I said that twice, you can slice them perpendicular to the base, and you can also slice them slanted, which we call skew. But I don't think any of those are skew ones. So let's take a look at these. Number 9 says, cut a triangular prism parallel to the base. So basically you take that triangular prism, if you set it on its triangular base and make a cut through the middle of it, that cross-section is also going to be a triangle. Cut a cylinder parallel to the base. Again, if you think of a cylinder that's sitting on its base and you kind of break it in half, that cross-section is also going to be a circle, just like the base. So generally with prisms, when you're cutting parallel to the base, the shape is going to be the same shape as the base. And then cut a rectangular prism parallel to the base, same here. That's also going to be a rectangle. Now, number 12 is take that cylinder and cut it perpendicular to the base. So that means we are going to, like take a knife, kind of like you would cut a cake, and you'd start at the top and cut straight down. And when you cut a cylinder like that, you're actually going to get a rectangle as the cross-section. So if you cut a cake in half and separate it and just look at it head on, you're going to see a rectangle there. You won't see the round part of the cake in the middle. All right, cut a rectangular pyramid parallel to the base. So if you think of a pyramid, I'm going to cut it, flat to the base, and so that's also going to have the same shape as the base. It's going to be smaller, but it's still going to have the same shape. So that's going to be a rectangle as well. And then finally, number 14, cut a triangular pyramid perpendicular to the base. So when I take a slice and it's perpendicular, that means it is going to go through at least two sides. Wait, let me think about this. All right, I've thought about it. I believe there are two answers to this question, depending on where the cut is. So if the cut comes at the very peak of the pyramid straight down, you're going to go through three different sides, and that's going to give you a triangle. So that's one possible cross-section. But if you don't cut through the very peak, somewhere on the side, and go straight down, you're actually going to go through potentially four different sides of the triangle and of the pyramid, and that's actually going to give you a trapezoid. That one's a little harder to see. And one thing you can try to do is really Google any of this. If you Google slicing a triangular pyramid perpendicular to the base, it'll give you a picture. It'll help you visualize it. So I do recommend taking advantage of Google and just typing in the description, and generally you'll get some kind of image that may help you visualize this. All right, next questions. So here's a couple of more slicing questions, but they're a little bit different. So 15A says, name two shapes that you cannot make by cross-sectioning a cube. So the shapes that are made when you cross-section a cube depend on how many faces you go through. And the maximum number of faces that you can slice through on a cube is 6, because there's not more than 6 sides. So that means that I can't have a shape that has 7 or more sides to it. I will never get that as a cross-section by slicing a cube. Okay, so name two shapes. How about an octagon? Because that has 8 sides. And a decagon, which I think you learned about last year. That has 10 sides. So those two have more than 6 sides, so we can't get a cross-section from a cube that looks like that. So the answer to the question, how do you know? I can't form a shape that has more than 6 sides. All right, let's take a look at B. What is the most sides the shape of a cross-section of a triangular prism could have, and how do you know? So with a triangular prism, at most that has 5 faces to it. Right, you have the top and the bottom and the 3 sides. So the most you can do, if you slice it very carefully, you can hit all 5 sides and get a shape with 5 sides to it, but that's going to be it. So the answer is 5. And how do I know? A triangular prism has only 5 sides. And that's as many sides as we can go through with a slice. So that's the most that we could possibly have. So remember, the general rule for figuring out these slicing problems is however many faces your slice goes through, that's how many sides the cross-section will have. That's the main rule. So you don't have to slice through every single face with a three-dimensional picture, but you can. But there are other options. So you know, like for a cube, you can just go through three sides if you slice it the right way, or you can go through four sides if you slice it perpendicular. So the number of faces you go through determines the number of sides of the cross-section. All right, let's see what's next. All right, we have some surface area problems, and this is all about the pieces. So looking at number 16, I have 1, 2, 3, 4, 5 different pieces, so I have to account for the area for each one of these. These three are rectangles, so that's going to be nice and easy, bases times the height. Then we have two triangles, and that's going to be 1/2 the base times the height. And just to be clear, this is my base and height. They have to make a 90-degree angle. This is my hypotenuse. We don't use that to find the area. We use the base and the height that come together at 90 degrees. All right, so let's see what we got here. Let's start doing the pieces. So let's do the rectangles first. I have a 3x4, and I have a 3x3, and I have a 3x5. There's my two rectangles. And then I have I have two triangles. That's going to be 1/2 3 times 4. And I have another one of those. And that gives us a grand total of, let's see, so we have 12, we have 9, we have 15. 1/2 times 3 times 4 is 6, and 6. And when you add those all together, let's see, what do you get? There's a 9 and 6 is 15. 15 is 30. 36. I'm getting 48. And this is surface area, so it's going to be centimeters squared, because it's area, not volume. All right, let's take a look at number 17. All right, so we have 5 different pieces here. We have these 4 triangles. 2 of them have a base of 6, and 2 of them have a base of 8. And then we have this rectangle in the middle. So let's account for all these pieces. So let's take care of the triangles. Let's see, so I have 2. The top and the bottom ones are each 1/2 8 times a height of 14. So we have 2 of those. And then we have the 2 side triangles. So those are each 1/2 base times a height of 12. And then we have the middle rectangle, and that's simply 6 times 8. So let's see what our grand total here is. Let's see, so each of the top triangles, that's going to be 1/2 times 8 is 4. 4 times 14, I think, is 56. So we have a 56 on the top and a 56 on the bottom. Bottom then top, of course. Then the 2 side triangles are 1/2 times 6 times 12. That should be 36 on this side, 36 on this side. Make a nicer 3. And then the middle is 6 times 8, so that's going to be 48. So the grand total is, going to my calculator, let's see, I have 56 plus 56 plus 36 plus 36 plus 48 gives me a grand total of 232 centimeters squared, because we're talking area. All right, next problem. So a couple more surface area problems. Number 18 is a cylinder. So the base is pretty straightforward, right? We know what the radius is, so we can find these two areas. And this rectangle, here's the fun part. So we can see we have a height here of 11, but what is this length of the base part of this rectangle? Well, I'm going to think about if you took our circular base and rolled it the length, you would get the circumference of the circle. So think about folding this up and wrapping it around. That rectangle wraps around one time around this circle, which makes this distance the circumference of the circle. So remember what that formula is. We'll need that, right? Circumference equals pi times the diameter, or it equals 2 pi times the radius. And of course, area of a circle is pi r squared. All right, so put all these together. So we have the two circular bases, and each of those are going to be pi r squared plus pi r squared. And then we have this rectangle, which is going to be 11 times the circumference, which is going to be 2 pi times 7. All right, so we have a lot going on here. So we have a 49 pi for the one circle. We have another 49 pi for the second circle. And then we have, let's see, 11 times 2 is 22, and 7 times 22 is what? I don't feel like doing that in my head. 7 times 22 is 154. So each of these has a pi term in them, so we can add them all together, and that's going to give us 252 pi, and that's meters squared, because we're still talking surface area, okay? So 49 pi again for the two bases, and 11 times the circumference, which is 2 pi r, 2 pi times 7, and then we add them all together, and we get the 252. And if you want, you can put 3.14 in for pi and get the decimal version of this to see, in case you did it that way. All right, another rectangular one. This shouldn't be too bad, but how many pieces do we have? We have 1, 2, 3, 4 middle pieces, and then we have our two rectangular bases. This is of a rectangular prism. It's kind of wrapping around these two bases. So we've got to make sure we account for all of these pieces. So let's do the wings first. I have a, I'm going to do the math already because the numbers are easy. We have a 40 and a 40, and I got those from here and here. And then we have a 170, which I got from here. And we have another 170 here, right? And then we have the two other rectangles. That's going to be 4 times 17 So let's see, 4 times 7 is 28, and get, I believe, 68 for this one, and of course 68 for this one as well. Okay, so I've accounted for all 6 pieces, and then my calculator is going to tell me what the grand total is. I get 170 plus 170 plus 68 plus 68 plus 40 plus 40. And I get a grand total of 556, and that's centimeters squared because we are talking area. All right, moving on. So we have a couple of area problems here where we are trying to find the area of the shaded region. So whenever you have a shaded region and then you have some holes in that you don't want to include in the area, you take the outside area and you subtract out those pieces that you don't want. So that's not too bad here because we have a rectangle on the outside. That's easy to see, and this is a 10.5. I know you can't read that here, but that's what the number is. And then we have 2 circles on the inside, and we know the radius, so we know the area of these two, and we can subtract those out pretty easily. So let's set this up. The outside rectangle is going to be 18 times 10.5, and then we're going to subtract out one of the circles, which is pi r squared, and we're going to subtract out the second circle, which is also pi r squared. I know it's not labeled, but they are identical circles, so they both have a radius of 3 in them. And let's simplify this a little bit. First of all, we need 18 times 10.5, and that's 189. Probably could have figured that in my head. And then we have a 9 pi and another 9 pi. So we could rewrite this a little bit more as 189 minus 18 pi. And you could stop there if you wanted. That's going to be centimeters squared because we're talking about area. But I think I might put 3.14 for pi and get the decimal version of this one. So let's see, we have minus 18 times 3.14. And that gives us 132.48 centimeters squared. Now 22 is really just a shaded area, but it's made up of 2 areas that we know very well. The top part is a triangle and the bottom part is a trapezoid. So remember, the area of the triangle is 1/2 base times height, and the area of the trapezoid is 1/2 base 1 plus base 2 times the height. Alright, so let's put these together. We have 1/2 times 6 times 9 plus 1/2 4 plus 6 times 7. And this, of course, is 10, right? So this is going to be 1/2 times 6 is 3, 3 times 9 is 27, and this is 1/2 times 10 is 5, times 7 is 35, which gives us a grand total of, I believe, 62, and again, that's going to be centimeters squared, because that's area. So once again, we took the area of the triangle, took the area of the trapezoid, and then added them together. All right, we're in the home stretch here. One more page. All right, this says, which of the following expressions represents the volume of the cylinder below? Circle all that apply. This problem is all about the different forms that pi can take. So we're going to find the volume, but we're going to take a look at it step by step and see if it matches any of the expressions below. So we know that volume equals capital B, area of the base, times the height. In this situation, that's going to be pi times 6.5 squared times the height of 10. All right, let's see. Is there anything down there that looks like that? Let's see. This kind of does, but it doesn't have the 10, so that's not going to work. I don't think anything else with the 6.5. This has a 6.5 squared in it, but it has 31.4, so I'm not sure about that just yet. So let's hold on to that. Let's continue doing the math here. Let's get the 6.5 squared down, and that would be 42.25. So we have a pi, and we have 42.25 times 10. And let's see if we have anything that resembles that. Is there a 42.25 down here? Here's a 44.25 and a pi and a 10. Okay, so that one will work. Anything else? Here's 422.5 pi, but no 10. But what happens when you multiply 10 times 42.25? You get 422.5. So this one is also a different version of it. All right, so let's see. Let's keep simplifying. Well, let me just do one more step here. This is going to be 422.5 when I multiply by the 10. And now let's put 3.14 in for pi, and we'll do that math. So if I do 3.14 times 422.5, I get 1326.7. And of course we're talking inches cubed because it's volume. So do we have anything that matches that? Well, we do. That one matches that. And let's see if there's anything else here that we can look at. This we knew. We eliminated that one because it didn't have the 10. This one doesn't make any sense. 13 pi would not be the area of the circle. That would be the circumference. Mm-hmm. So we can knock that one out. This one didn't multiply by 10, right? It's like this answer but divided by 10. So it didn't multiply by the height, so we can knock that one out. I don't know where this one came from. There's nothing even close to that one, so don't have to worry about that. But what about this last one? This is a little, this one's a little bit different. If you compare this one to, let's see, well, we have 31.4 times 6.5 squared. So what is 31.4? If you really think about that, that's 10 times pi, and when pi is 3.14. So that also has the three pieces that we found up above, 6.5 squared, the 10, and the pi. So that means that this one is also an answer. All right, so there you have it. There's the answers to all of the review problems. We'll probably do a couple more in the forms of a do now in class. If you have any questions, you can see me at lunchtime or at SOAR, I believe, all this week. And again, the test is coming up on Thursday. All right, I hope this helped.